We trust the most important things in our lives to software. It's your healthcare, your finances, your social life, your government, your elections, your military defense, all that. You're trusting software with that, with really no reason. And I think that's a little bit crazy. So I think the world is changing. We'll talk about why a little bit. Problem is that we probably shouldn't trust that code very much. I've spent 20 years analyzing applications. I did lots of manual code review, manual pen testing, run tools on applications. I've done threat modeling. On average, this is the kind of numbers that we see. Your application is probably 20% custom code and 80% libraries. Of that, by the way, if you look at just the code that actually runs, 2/3 of it, the top of the iceberg, is custom code, but only that little green piece, 1/3 of the application is open source libraries, mostly custom code. But on average, your custom code has 26.7 vulnerabilities. That's a lot. Imagine if we were building airplanes, and every time you did a safety check on the airplane, you found 26.7 safety problems. Nobody would fly. But we run these applications in production all the time. And you also have a few open source vulnerabilities in your application as well. So we're not really that good at writing secure code. Oh, and by the way, the bad guys aren't sleeping. The average application that we monitor, Contrast analyzes hundreds of thousands of applications and APIs all the time. And in production, we see 5,000 attacks per app per month. So you're getting attacked, and you've almost certainly got vulnerabilities. That's not a particularly great place to be. So some of that trust is unfounded. And we know that we're not delivering on the expectations people have. People expect applications to be perfect. And we know this because every time there's a big vulnerability or a breach, like log4shell, anybody have to deal with log4shell out there? A number of people. Those kinds of problems, people get outraged. Congress gets involved, governments of the world get involved, and they're super upset because our expectations don't match reality. People expect a much higher level of security than what the software industry is delivering. And it's kind of silly. Every company I've worked with is in the same boat. They all have all kinds of vulnerabilities in their applications. It's just a fact. That's where we are. So the governments of the world are stepping in. And I think this is particularly fascinating. In the US, about a year and a half ago, the administration issued an executive order. They said, hey, we can't have this situation. We need more visibility into what's going on inside applications. What have you done to secure this code? So they demanded everyone who's selling software to the US government, they have to generate SBOMs. Anybody know what an SBOM is? Software bill of materials. Anybody heard of that? It's basically an inventory of the open source libraries that you're using in your applications in a specific form, in a machine-readable format. You're gonna have to generate that. You're gonna have to disclose that if you want to sell to the US government. And by the way, it's sort of like a transitive problem. If you sell software to a company that sells software to the US government, you're gonna have to end up generating these things. So I think pretty much everybody's gonna have to start generating SBOMs. They're also gonna have to attest to the fact that they've done good security practices like testing and patching and so on. So they're forcing companies to be transparent about the things that they do to make sure code is secure. That's a big change. I helped to start OWASP 20 years ago and wrote the OWASP top 10 20 years ago. Anybody seen the OWASP top 10? Just quick. Okay, so I've touched a few lives in here. Sorry about that. But nothing has really changed in those 20 years. It's actually even the same stuff in the top 10 that it was 20 years ago. I had this idea that we would like slowly get better and we could move some things off the list and move new things onto the list and gradually raise the bar. That didn't happen. It's still the same stuff. SQL injection, still in the OS top 10 after 20 years. So that's kind of frustrating. But I think it's going to change. because people are going to demand visibility into it. So it's kind of, sorry about all that's bad news. So what's the good news? Good news is DevSecOps will fix everything. That's sarcastic. I don't know. You guys get sarcasm here, right, in the UK? I've heard you guys. So it's interesting. The problems in security are very similar to the problems that software had that caused DevOps to get created, right? 10 years ago, software's poor quality, it's being delivered late, it's slow, doesn't provide great business value. So people rolled out DevOps, and organizations that are high functioning at DevOps have pretty incredible numbers, great feedback. And so the obvious thing to me would be to try to do for security what people did for software quality with DevOps. So you could imagine a program that's like, hey, security is poor quality, it's late, it's slow, and it doesn't provide business value. Same problem. Can we try something like DevSecOps? And maybe we can get things like, much faster security results, way less vulnerabilities into production, no delays in time to market, things like that. Unfortunately, what happened was that people didn't really transform the work of security. DevOps, if it's about anything, it's about changing the work of building software. You went from these big monolithic releases that took, on my first software project, I worked on it for 3 years, and we never delivered once. We never deployed one piece of software. Now it's, continuous delivery, but security doesn't work like that. Really, I think what happened was we just took the same security practices that we'd been doing, and we shoved them onto developers. It's not shifting left, I call it shitting left. And if you think about this picture a little bit shows it. It's like we tried to jam security activities into each stage of the pipeline, right? Like early in development, you do some scans. A little later in the CI/CD pipeline, maybe do some scans, maybe do some testing later, maybe put a WAF in production. The problem is all of those technologies are super inaccurate. They have lots of false positives. And when you have false positives and false negatives, you have to have humans come in and clean up the mess. That's really the only way, right? You need an expert to determine if something's a false positive or if you've missed a vulnerability. So really what these tools do is they're not automating security, they're just generating work. And so if you think about all the vulnerabilities pouring out, there's some red dots and some black dots. Those are like real vulnerabilities and false positive vulnerabilities. That's all just work. And it takes a lot of people to clean that up. And you used to have a big appsec team that might clean that up. Now maybe it's development that has to clean all that up. But ultimately, I don't think this is very great for developers. It's certainly not great for security. And what we see in almost every company that does this is you end up with a big security backlog. Anybody got a pile of vulnerabilities that they're not remediating? Got to talk to some people beforehand. That's, maybe it's like all the mediums and lows. Maybe it's some other slice of the vulnerabilities. But a lot of stuff doesn't get remediated, and we end up with a lot of vulnerabilities that end up in production apps. Okay, so I'm going to shift gears. Instrumentation is really powerful. In basketball, we got a problem. I play a little basketball. I'm actually on the US national 50 and over team. We just won a tournament in Utah, actually. And in basketball, we got a little bit of a crisis. There's too many players in the United States, not enough coaches. And so one of the things that kids are doing is they're starting to use instrumented basketballs. These are balls with sensors in them. They detect how fast you dribble, your crossover speed, the arc of your shot, your makes and misses, a whole bunch of stuff. Fantastic. Comes with an app, and the app will coach you, give you drills, what to do. It's actually a virtual coach. And if you think about the way it changes the dynamic, now the player can do most of the work themselves. They can get feedback, they can get some coaching, they can improve their skills on their own, and the real coach can now be more strategic. They can take a step back. They can say, hey, let me look at my whole team. Let me work on problem areas. Like they can get the data from all this and say like, hey, this player has a problem with this skill. I'm going to work on that. Changes the math. Lots of things are like this. Healthcare is like this. If you're trying to battle an epidemic, you need instrumentation to go measure who's getting sick. Anybody here wearing a Fitbit or an Apple Watch? Same thing, guess what? You are instrumented. And pretty soon your watch is gonna tell you when you're sick before you know. Doctor doesn't have to be involved. Maybe can get involved more strategically. I don't know, I don't go to the doctor very much. But I would love it if I had a doctor that was monitoring my telemetry and telling me when I've got a problem coming to, like, hey man, your heart is freaking out. Oh, I didn't know that, cool. So look, instrumentation changes the game. So we can instrument software. We can instrument it for security. And it's really powerful. Here's how it works. So imagine you've got a typical stack for an application. Runtime platform, you got some libraries, an app server, and some custom code. To instrument an application works just like an APM tool, like New Relic or App Dynamics, right? You can add an instrumentation engine, and what this thing does is it instruments the code as it loads. So you don't have to change anything about the way you build, test, or deploy your applications. Just on your app server, as the code loads from disk into memory, we're gonna add some sensors into that application that are gonna monitor security critical behavior. So let's say I put sensors on calls all over this stack. Things I care about, things like runtime.exec, or if I'm log4j, maybe I put it in the JNDI engine, things like that. We can add these sensors, and then as the application runs, as you use it during your normal QA activities, you're gonna generate some traces. You're gonna generate events. And if you string those events together to follow like each thread of execution, for instance, you'll see patterns of behavior that represent vulnerabilities. And the cool thing about this is it's super accurate. We're directly measuring the application that we're trying to analyze. So it's not like we're looking at the source code or looking at HTTP traffic or something that's I kind of think of that as like outside in. This is directly measuring the thing that we're trying to analyze. So let's dig in a little bit. I'll give you an example. So let's say we had a little code that looks like this. The top is a pretty generic SQL injection example. We're taking some parameters from the HTTP request, we're shoving them into a SQL query without parameterizing them or escaping them in some way, and then we're sending that to the database. Attacker can send an attack in that parameter and take over your database, change the meaning of the query to do whatever they want. So we can detect that using instrumentation. We can see this pattern. Let's look at how the events look. So the first event we would see is getting the HTTP parameter. Then we would see, well, in this case, we get two HTTP parameters. Then we track those parameters through the running code. So we can see here, we're building a query, we're tracking like string appends. We can track those events too. So we're doing data flow analysis inside the running application. When we track that data all the way to the bottom, we get into a SQL query. And when we look back across that trace, does anybody see any like parameterization or escaping call in there? It's not there. So we know that this is an exploitable SQL injection vulnerability. The data flowed from an untrusted source into the query, and we know the right defense wasn't there. So we know it's vulnerable. This is way more accurate than sort of static techniques that just look at the code, or DAST techniques that can only see HTTP attacks and so on. So you might be sitting in the audience saying, okay, big deal, Jeff, it's another security tool. I already got 4 security tools, I don't care. Well, this is really game-changing to me, and why I get so excited when I talk about IAST is because this is democratizing. This means anybody can do their own security analysis on their own code. You don't need to know anything about security. To find that vulnerability, we didn't type in any crafty attacks, or we didn't know about SQL injection. We just used the application normally. Your normal QA tests, whether they're manual or automated, can detect vulnerabilities. Really complex vulnerabilities. Things that even human code reviewers like me, I actually really like code review. I thought I was good at it, but modern applications are really complicated. To trace data manually through a modern framework and all the auto mapping magic that happens under the hood is really hard. But IAST sees it all. It sees the whole stack and everything that happens within that. So this is really transformational. This empowers any development team to do their own security and tell the security team to like, hey, get out of here, I got it. It's really nice way of doing this. The results are really impressive. This is something called the OWASP benchmark. This team at OWASP created a set of test cases for tools like this, for application security testing tools. They made 2,700 test cases, half of which are true positives and half are false positives, and they test how well you can do against this test. So you can take whatever tool you're using, I don't care, it's SonarQube or Fortify or whatever tool you're using to test your application, you can just clone this. It's an open, free and open, totally reproducible benchmark. You can plug in your tool, run it against the code or whatever, get a report, and feed it in, and it'll generate this for you. And where you want to be, you don't want to, like DAST tools tend to end up down here in the lower left corner. They find some things without a lot of false positives, but they miss a lot of real vulnerabilities. So if you're trusting your company to a DAST tool, you got to be a little concerned. You're going to miss vulnerabilities. Static tools tend to be in the upper kind of right-hand side, where they find vulnerabilities, but they bury them in loads of false positives. So they make it very difficult to use. IAST is really exceptional here. It finishes this, and it does it in almost real time, which is important. If you want to add security to your pipeline, you want it to finish really fast. For this application, there's 2,700 test cases. Veracode takes an hour and a half. Checkmarks takes 40 minutes to run on this. IAST finishes in about 16 seconds. That includes the time that it takes to run the set of end-to-end tests. So it's really only adding a few seconds to the process. That's nice, because you can get your feedback in real time. Anytime you run your test, you get instant feedback on your code. You can fix those vulnerabilities and check in clean. It's very tight feedback loops. And if you remember, tight feedback loops is like the second way of DevOps. That's what we're shooting for here. So when you put it all together, this is kind of what it looks like. Deploy IAST on your servers, whether it's in development or QA environment or in your pipeline, wherever your code runs, wherever you're running end-to-end tests. You get instant feedback. You can get it in a dashboard. You can also get it back into the tools that you use. Like, you don't have to go to some separate dashboard. You could just get a feed of this in Slack or Jira or right in your IDE or however you want to consume these vulnerabilities. So I'm going to go through a few benefits that you get from this. The first is, we've talked about this, you get what I'll call runtime vulnerability snapshots. It's not like a vulnerability report. It's literally snapshotting what happened in the application itself as it runs. So you'll see a nice story that tells you, here's the data that came in, flowed through the application to this method on this line of code, and ended up in this SQL query. That's nice. Like, static tools only show you the middle piece. Dynamic tools only show you the top piece. And no other tool can show you like the actual query. But if you're a developer, this is kind of, you want to see all of this. You want to understand exactly what's going on. And under the hood, it's got, the full HTTP request. So you've got a test case that you can replay to verify that you fixed it correctly. And it's got the, snapshots of every step, including the full stack trace of every step through the code where this vulnerability happened. So you get a really complete contextual vulnerability that you can actually fix. I spent a lot of time trying to correlate, like figure out, like if you get a static analysis finding, you don't know how to make that code run, so how do you really test it? It can take a long time to go figure out, like, how do I actually make that code run with data to prove that I fixed it right? Second thing you get is what I'll call runtime library analysis. So, if you dealt with Log4j, you probably got to keep your libraries up to date these days. Problem is, as I mentioned in one of the first slides, the iceberg slide, I said 62% of libraries are never invoked at all. They're just transitive dependencies that never get loaded by the application. And so if you want to focus on the libraries that actually matter, you should look at the ones that are actually loaded and run by the application. So by doing it at runtime, you can do that. IAST can see exactly which libraries are used and how they're used by the application. So here you can see, we can show you all the details of vulnerabilities, but we can also show you, see this classes used? We can show you exactly what classes are used by each application. Personally, I think most people do code analysis and library analysis with two separate tools. And it's weird to me, because they're combined into one application. They're interlinked in all kinds of different ways. And so to really understand how it all goes together, you got to analyze them when they're put together. So it should be one tool that analyzes your custom code and your libraries all at once. But just the way the market developed, there's two separate classes of tools that do that. I encourage you to look for tools that do this as one thing, one activity. And while I'm on this, you should use a tool like this to generate SBOMs. Like using a runtime tool can generate SBOMs for your application. That's that software bill of materials. You're going to be asked to deliver an SBOM within the next year. I almost guarantee it. So keep an eye out for that. This makes it really easy. Next thing is what I'll call runtime route coverage. So when an attacker looks at an application, an attacker tries to understand what we in security would call the attack surface. You might think of it as routes. Like, what are all the endpoints that an attacker can target? The way IAST looks at that is IAST interrogates the framework to figure out what are all the routes that are possibly accessible through this application. Other tools, they don't have a good way of asking that question. So like static tools, they don't always know all the entry points to the application because they don't understand the framework that well. So with IAST, you can automatically get a list of all the endpoints, and IAST will keep track of which endpoints have been tested. So as you do your normal testing, it'll start checking off boxes. Say, yep, got that route, got that route, got that route, got that route. Then at the end, you might look at it and say, like, and in my example here, you can see I've got 25 routes. Only 21 of them were exercised. And in this particular application, it was a Spring Boot application. In this one, I looked at them and I was like, those routes aren't anywhere in the public-facing web interface. Like, there's no way to figure them out. And I dug into it, and actually those routes are added by Spring Boot automatically. There's like a configuration option to turn them on. They're like debugging routes. And they disclose log files and environment variables, and actually you can even get a heap dump through those APIs. So we went back to our customers and looked for this pattern, and lots of customers had these routes turned on. They didn't know it, but they were exposing heap dumps of their application to whoever wanted them. So this is important. Understanding the attack surface of your application is really important. This way you can ensure that you're actually testing all of the endpoints that are exposed, and you can drive to 100% test coverage. That's something you can't really do through traditional kinds of application security. Then the last piece is what I'll call runtime architecture diagrams. IAST can automatically watch your application run. It can see what the architecture looks like. It can see all the back-end connections, and here you can see APIs and databases, and oftentimes we'll see things like LDAPs and socket connections and MQs and things on the back end. That is super helpful if you're doing threat modeling or you want to understand just like what the architecture of your application is. Watching the application run is a really smart way to kind of build that picture. I used to do a lot of threat modeling, and I'd often walk into the room and someone would slide me a bunch of Visio diagrams that were written 3 years ago, and they're way out of date. This is a really nice way to get really up-to-date information about what's really happening inside your application. And then some IAST can actually look a step further and say, hey, what other applications connect to those same back-end systems? So you can start to think about, like, what's the risk? Maybe this application is like the lunchroom cafeteria menu that nobody cares about from a security perspective. But look, it's got access to this database, which is being accessed by the corporate financials application. So it's a way of trying to understand risk in context in your application environment. Okay, so those are four of the major benefits of using IAST over sort of traditional static analysis tools that are just going to produce you a PDF report full of false positives. It's easy to deploy IAST at scale. You can use a bunch of different ways. It's exactly the same as deploying something like New Relic or App Dynamics. It's really just pushing it out to all your app and API servers. You can use a Kubernetes operator to push that out to a whole cluster at once. You can use a gold server. I encourage you to think about deploying it at scale rather than like one app at a time. But remember, IAST is a fully distributed solution to application security. So instead of scanning each application one by one and building up you never get the full picture all at once, IAST works in parallel across your entire application portfolio. All your applications are being tested in parallel, and the telemetry is coming together in real time. So you always have this sort of complete picture of everything that's going on in your application portfolio. Okay. So that was a lot of details. Let's zoom way back out, okay? So when I think about DevSecOps and getting secure code really moving into production, I think about using IAST as the way of helping this. I think of it as self-testing, and like that's the way it's easy to think about. All your applications are testing themselves, and data's coming, reporting in. So imagine that you've got that, and every time you change code, you're getting instant feedback. You can make very tight feedback loops. In fact, it brings development and security together. What I see in a lot of organizations is development and security naturally veer apart because when you run the security tools, you generate all these false positives. There's a lot of work to clean those things up. And it means people develop certain expertise in handling those findings. So they become a separate group that provides that function. It naturally silos itself when you do security that old-fashioned way, when you have false positives. But with IAST, it drives security and development together. The QA team and the security team now have, their interests are aligned. They're both interested in driving up route coverage, driving up QA coverage, because everything that you do QA on, you also get security testing on. So now, instead of having two separate infrastructures, one to do QA and one to do security testing, now it's one infrastructure. It's all driving the same process. So it can bring security and development together in a way that I don't see in a lot of companies. The other thing that I think is an important driving function for DevSecOps is to get a policy in place that says, what's good enough for an application to go into production? You can set whatever policy you want, but if you can articulate it in a way that development teams can implement automatically, then they can take control of security. They can be empowered to deliver product into production at whatever velocity they want to go. As long as you meet these criteria, and you can choose your own criteria, I suggest you say, hey, if the code is clean, like let's say you made a rule that says, hey, we're not going to have any vulnerabilities higher than a medium or something. You could set that rule. You could create some other rule. You have clean libraries, meaning you're not using libraries that have known vulnerabilities in them, if those libraries are actually used by the application. And you have good route coverage. Maybe you say 80% route coverage initially. We have a number of customers that have gotten all the way to 100% route coverage, by the way. It's not hard. It's not like test coverage, where getting to 100% is unrealistic. Route coverage just means you have one test for every exposed endpoint, just a smoke test that just drives that code a little bit. So anyway, you can set some criteria and say, hey, this is the definition of done. And then developers can take control of it. They can say, okay, I get it. I know enough to fix this and get myself to a place where I can deliver code to production as fast as I want to go. I think this is empowering. Okay, a couple of metrics that I think matter when you're talking about DevSecOps. The first is mean time to remediate. So one of the major static analysis companies, I won't name them, they put out a paper every year where they look at all their data across all the applications that they secure, and they say, For static analysis, it takes 290 days on average to remediate vulnerabilities. That's a pretty long time. It's like 3/4 of a year. With IAST, what we see is very different. We see mean time to remediate is less than a week. We got a number of organizations that are doing it in less than a day. That's because this approach works. You can't get to less than a week if you're not empowering developers to do this on their own. That's the sort of the light bulb turning on moment that we see in a lot of organizations is they can fix these vulnerabilities really fast without a lot of hassle. They do it themselves, and they get to a place where they're clean. They're cleared to go into production as fast as one. They're not carrying a big backlog of security vulnerabilities around, slowing them down in every single sprint, deciding whether to do this or not. The next metric is what we call the vulnerability escape rate. So finding and fixing vulnerabilities fast with MTTR is great. But it would be even better if we didn't introduce those vulnerabilities in the first place, right? Then we don't have to find them and fix them at all. So that's super fast. So what we see with SAST is that projects are introducing 10 new security vulnerabilities every month. That's a lot. With IAST, we see and it doesn't change, by the way. It'll just stay at 10 forever. With IAST, we see a learning effect. We see this number come down pretty quickly over the course of the first year, down to less than 1 new vulnerability a month. Because when developers are getting instant feedback on their code, showing them exactly what was driving the vulnerability with all the details, they can learn that. And say, hey, that's what causes SQL injection. I'm going to change that practice and not do it anymore. So you can drive the vulnerability escape rate down to a point when 1 vulnerability a month is really pretty easy to handle. It's not a huge amount of extra work on projects. So I encourage you to measure what this looks like. In fact, you can add up how much you're spending on application security in the course of a year. Add up the cost of the tools, all the triage effort that it takes to diagnose false positives, all the time it takes to remediate vulnerabilities. Add all that up, you're probably at $30,000, $40,000, $50,000 per app. You can add up your own numbers, but it's expensive because triaging false positives takes a lot of time. With IAST, you can drive those numbers way down because a lot of that triage cost goes away. The remediation cost goes way down because you're fixing it right immediately. When you don't have to start a whole ticket, you just fix it right then in the code. Okay, so that's IAST. Hopefully you got a little bit of knowledge about DevSecOps. I'd love to take any questions. Please use the app to ask them, or you can just raise your hand and ask any questions. Yes.